This is unit number 5, video 17, the calculation of the excess reactant. We've already talked about excess versus limiting reactant. The excess is the one left over. When you run to a reaction between two chemicals, or it could be more than two, but primarily two, one of them is going to run out. I guess you could set it up to have exact ratio, but one of them is going to run out. And when that one runs out, the other one's left over. That's our excess reactant. So I'll give you an example of the candle. You know, we could burn that candle for a little, we could weigh the candle before we start. Then we could burn the candle and put the cup over top of it, let it go out, and then go weigh it again and see the new weight. The new weight would be the amount of the excess reactant remaining. So it's remaining. We could calculate exactly how much has been burned. So let's go to a calculation. We did this calculation in the previous video. The combustion of C2H4, we call this ethylene, and it produces carbon dioxide and water. We did the calculation of the theoretical yield of CO2 and proved that the limiting reactant is O2. Okay? Limiting reactant is oxygen. The excess reactant is C2H4. This is a good point, good time to make the point. Limiting reactant and excess reactants are reactants. They're not products. So CO2 cannot be a reactant in this case because it is a product. So one of these is the limiting reactant, the other is the excess reactant. Okay, so what we're going to do is calculate the amount of the excess reactant remaining when the reaction's done. Some of it got used. We can figure out how much got used, subtract that from the original amount, and that'll give us the excess. So what I'm going to do is take my theoretical yield and calculate the excess reactant. That'll tell me how much was used to make the CO2. So 2.98 grams of CO2. Go through, and I'm going to divide by the molar mass of CO2, which is 44.01. Then I'm going to convert this to my excess reactant, which is C2H4. Okay? So on the bottom is going to be CO2. On the top is going to be C2H4. I know there's one C2H4 for every two CO2. Go through, and I'm going to use the molar mass of C2H4, which is 28.06. When I go through, punch this into the calculator, I'm going to get 0.95 grams. Really should be 0.950 grams, three significant figures. So I have 0.950 grams. So this is not the amount of the excess reactant remaining. This is the amount of the excess reactant consumed. So now I'm going to go back to my original amount, 4.950 grams, subtract 0.950 grams, and that will give me the amount remaining. 4 grams of C2H4 will be remaining at the end when the reaction is completed.